Hi folks, welcome back to Physics with Captain Rod. I'm making this one to help you out with number 12 on your Unit 2 homework. So let's see, we've got this 500 Newton force applied to this rock. Assume frictional coefficients of 0.3 and 0.4. Now, this is pretty typical of how I usually word these. There's two different frictional coefficients given, and these are for the coefficient of static friction and the coefficient of kinetic friction. And I expect students to know which of these is which just based on the numbers. All right, so looking at the directions here, draw a free body diagram of the rock. So I'm not going to do that for you, but I'll talk a little bit about the force vectors. All right, the rock has a reasonable weight, due to that 200 kilograms. So make sure you get a force vector for that. The rock is not, falling through the earth, so to speak. It's being supported in some way, shape, or form. So there's going to be a force at this surface right here. Think about what type of force that would typically be. And if there were no friction, this rock would start accelerating to the left. Right? Now, it may or may not be accelerating in this problem. If there were no friction, it for sure would be accelerating. I usually make these up off the top of my head, so I don't really know if it's going to accelerate or not. But that's going to mean there's a frictional force on the rock, so put that force vector in and make sure you put it through its correct line of action. And that's what the free body would look like. All right, now as far as answering these questions, all right, find the normal force between the rock and the ground. Now, the rock is not going to accelerate up, and a quick glance of that, hopefully, you would have concluded that too, but roughly speaking, this rock is 200 kilograms, so it's got a weight of approximately 2,000 newtons, right? mg with g being about 10. There's no way that a 500 Newton force is going to lift and start accelerating that 2,000 Newton rock. So we know that the acceleration in the y direction is 0. So from your free body, you're going to write a force equation, and it should look like the sum of all forces in the y direction, again, is going to be 0. Doesn't matter which direction you define as positive. I'll just do this here. So this is how you get the normal. As a general rule of thumb, you get the normal by summing forces in the direction of the normal. Well, the normal in your free body should be in what I generally would call the y direction, kind of upward. All right, to answer question C, will it accelerate or not? Well, when you're dealing with friction, a lot of times it's very helpful to just kind of do some comparing force vectors here. The 500 newtons, if you write it in component form, it has an x component and a y component, and this is one way to draw those. Now I drew them over and up. You could also draw them like up and over, but that doesn't matter for this discussion. Calculate each of those components. And what you want to do now is compare this one to the frictional force. Now, being more specific, what you need to compare is this force vector to the maximum possible frictional force, right? So, how do we do that? Well, your maximum possible frictional force is your coefficient of static friction times the normal. And the static frictional coefficient was given up above, and the normal force you found under part B. I guess I'm writing in the part B slot right now. Sorry, give myself a little room here. But so calculate the maximum possible frictional force and then compare it to this. And if the maximum frictional force is larger than this force vector, this thing's not going anywhere. If the maximum frictional force is smaller than this vector, then this rock is going to start sliding to the left and accelerating to the left. And as an added bonus, if you know it's accelerating, then you know to use the kinetic coefficient of friction, or what I sometimes call the sliding coefficient of friction. So I would go back then and calculate the frictional force, the sliding frictional force, and then write a force equation. Sum of all forces equals mass times acceleration in this direction. And that should give you the acceleration of that rock. So that's probably enough on this problem. I hope that this helps. Have a great day.